Hello everyone, welcome back to another tutorial. This tutorial will be split it into three parts. First part, I'm gonna um, answer some questions of one of the background that I think all of you will be interested uh, in this. So he asked about the Particle Life system that we built in the first tutorial. Uh, so I will cover it up again in more detail, and I will try to make it much more clear because it's an important part of the whole system. The second part, I'm gonna show you some updates that I did to the component. Uh, mainly, let's see. Mainly, it's about how to basically take any texture and to make particles out of it. I've showed it in the last tutorial, but one problem was to basically fit it into the same resolution. So here you can see the original image, and here it's the final result, and you can see it's like the same resolution, and it's like not cropped or something like this. It just looks quite similar. Um, so I've added some features that to make it much more convenient, um, and I will cover it up. And in the third part, I'm going to show you how to use function stores ComplexOp with my system. It's a really nice component that he developed, I think, maybe 2 years ago, and I finally found it, found a reason to use it, a good reason, and a nice implementation that I really like. Also, I'm using function stores tools. You can see here, like I have this new bar and like crazy features that he developed. So it's totally free. Also, the ComplexOp, it's free, and I will link down uh, uh, um, a link to download it from his Patreon, and also the tools are free, so I will link it down, and you can use them. I will show you like a quick example of a nice thing that I'm using from it, from the tools. But let's begin with the first part. You can also skip between the parts if you feel like. I will try to make a timeline in the video. Okay, so yeah, I think this is enough for the introduction. Let's go inside this project, and I'm gonna show you and explain about the particle life system. So we have the component here. Let's go inside the component, and we can see here is the life system. All right, so basically, before we dive into the system, the particle life, it's a component that basically generates the life of the particles, and it's very important because um, without it, uh, the flow of the movement of the particles will not be continuous. Let me show you quickly what I mean by that. So if we go to the position, in this component we add the force and we calculate the new position. So um, this is like the position output, right? Let's open it up, and we can see our particles as points, and we can see them move. Um, So here it's where we basically take the dead particles and basically reinitialize them to their initial position inside the feedback. So if we bypass this by maybe just we'll add a null here and bypass this, so you can see that slowly the movement is less notable because we add small amount of force to the particles in each frame, and after after a while they are like attracted to the point of the force, to the vector of the force, and then all the movement disappeared. So with the life, basically we keep generating them to their initial position, and then the movement is continuous. So if I put it back here, you can see the movement is continuous. So that's why it's very important to have this life, and also important to know what's going on inside, because it's a it's a nice it's a nice thing, and I think that the math behind it's simple, but because it's with nodes and stuff, it's a bit looks a bit scary, but it's really not. And you can, with this technique, I think you can implement other algorithm, or to use it with for other reasons, I'm sure. So let's start here. We have here the initial values. Um, let's So what we want is basically to generate random numbers that will be that each pixel will be the age of the particles, the maximum age. Um, and so basically what we do, we use a noise uh, with random, um, and the offset to 1 and the amplitude to 0.5, which basically offset is like the average life, and the amplitude is the variance. So all those pixels are basically in between 0.5 to 1.5, and that way it's important because we don't want the life of all the particles to be the same, because then they will die and burn in the same time, and it doesn't look really good. um, so we randomize it, and we make the pixel format 32-bit float mono plus alpha. I will explain later on why this alpha, but the mono, basically what we need is it's a single value, right? So if we put, for example, a constant here and we make it 32-bit float mono, so its values will be R, G, and B will be basically based on the R value. So if I change here to 0.5, so also the G and the B will be 0.5, and the other channels are not considered because it's mono. And this is what exactly we need. We need only single value to play with. Um, yeah, and then what we want to do is to create feedback loop, okay? And inside the feedback loop, in each frame, we want to subtract a small number to the values, to the life, and then detect when a pixel is below 0, and when it happens, we want to initialize it to the initial value. That way we have like a endless loop that values are starting from a point, going down, hitting the 0, and then initializing back. So this constant, we basically this constant is this small number, and we grab the resolution. We need the same resolution, so we grab the resolution from the noise by connecting it like this, and in the output tab we set resolution only. We can do also like just constant like this and make the resolution the same reference, and basically it's the like, like this, and it's the same, but it's faster when you, for my opinion, faster when you connect it like this and make make the output set resolution on. Then we apply this small number into the red channel, because it doesn't matter if I put it here or here, the whole three channels will be the same value, as I said before. This small number, it's basically the step parameter, that it's basically a fixed number. It's 1 divided by 60, which is the frame rate, and it's multiplied with another parameter, which is the speed, which is not fixed, and we can play with it, and that way we control the speed of the simulation. So if this number it's big, so the particles are dying faster, and then yeah, it's not the speed of the simulation, it's like the speed of the death of the particles. Yeah. um, so yeah, we take this value, right, and we connect it into a subtract, and we're doing a bunch of stuff over here before. So basically, if I ignore these and connect it like this, right, so this is actually a feedback. So feedback, it's the current value. Always think about it like this. So this is a feedback that's taking the subtract. So it's basically a loop, okay, that goes like this, and each frame it's subtracting. So if I pulse it, we get basically those initial values that are being subtracted with this constant, and basically it will go decrease into a negative infinity. So this is why we are doing all those calculations over here to detect when pixel is below the 0, and then initialize it. So what we're doing here is we have basically two groups of particles inside the of values, sorry, um, inside the loop. One is the dead particles, so we have a threshold that says greater than 0. Okay, so essentially what's happening is like um, the values here, that the pixels that are white are the pixels that are less than 0. Okay, and the other threshold, it's the second group, which is basically the opposite. The white pixels here are particles that are still alive, means that they are still uh, above the 0. So we split it into two groups, right? And if we add these two groups, it's basically the whole values together, because it's splitting it into above and below 0. So now what we need to do is basically, if a particle is dead, so we need to grab the initial value of it. All right. So what we have here, it's values between 0 and 1. 1, it's the particles that are dead. 0 is the particles that are still alive. So if we multiply it with the initial values, we get the initial values of the dead particles. All right. So those white pixels are not really white; they are like these values. And in the second group, what we need particles that are still alive. We need to grab the current values of them, because they don't need to be initialized. They need to be in the same values. So we take from the current value, which is the feedback top, and also multiply it. All right. So yeah. So essentially, we have two groups: the initial values of the dead particle and the current values of the still alive particles. And we use an over to basically add them. You can also use an add over here because, as I said, it's like two splits it into two groups, right? So they won't overlap. That's what I mean. So if you use an add, the values won't overlap and it will be good. So yeah. So here we have all the values that we want, and we keep subtracting it. So we subtract this to this, and it's like an endless loop. All right. And then we get what we want. So for example, I don't know if it's clear, but you can see the values are going down. When they get to 0, they are initialized. So it's an endless loop, and this reorder basically grabs the basically turns it into 32-bit mono, because to this texture we actually we don't need alpha, it doesn't really matter. Um, and this thing, if we are here, let me explain. It's like if you pause the simulation, it generates like a new noise with a new seed. Just each simulation will be a bit different. And yeah, so what's important here, it's this texture, the dead particles. It's the location of the dead particles, right? In the texture world, basically. So if we go in the position, what we have here, it's the same texture, okay, the dead particles. And then we multiply the dead particles with the initial position of the particles. So we get the texture which has the location of the particles that are dead, and we with this over, we're basically um, overlapping, okay, those values on top of the current position, which is the feedback. So that way, when a particle is dying, is dead basically. So the pixel here, for example, a pixel, it will change into another pixel, which is over here, which is the initial position of the pixel. Um, yeah, and that's why we need it with an alpha, because if it wasn't with an alpha, for example, if it was, let's grab just a reorder and make it 32 mono without alpha. So sorry, like 32 RGB. Yeah, sorry, maybe a little level. Oh, excuse me, I meant this one. Change it to yeah. So the background will be 0, and if we do an over, so all the 0 values will be on top. So we need also only the pixels that are dead and the background to be alpha. All right. Hope I hope it's clear. And if you have more questions, uh, please let me know. I think let's continue to the second part, which I will show you the updates that I did. So as you can see, we have here the original image and the final image with the particles, and we can also use another texture, another image, which is with different resolution. Here in the switch, let's switch it, and if I reset, so yeah, very nice, and you can do a lot of stuff with it. Um, so let's see what's going on here. So we have the particle system component and the 2D render component that basically are working together. In the particle system component, and what I changed here, I didn't change anything. In the forces, there is the perpendicular force that was just implemented when you use the slope, but now it's also implemented to the whole force that you put here, no matter if it's slope or not. And I think this is it. Um, and the main part that I update is the render. So here you have a toggle switch with fit to texture. So without it, you can see it's not really fits the texture. And if you fit it and pulse the reset, you can see it's like automatically fits it because it's basically talking also with the render over here. I will show you in a minute. So what's happening here is basically we have the texture on the right that is going inside as a force. Okay, so I'm taking it from here and basically doing like a thresholding if you want to sometimes it's useful to if you don't want the whole texture to be with particles, so you can do like a threshold. It's the same with the life, basically threshold and then multiplying with the same texture, and then it goes into a level that you can also play with and make it stronger if you want. And this is the force that is going inside the external force, right? And of course you can play with all the parameters of the force. It's not the focus now. And also in the render you can do like a costume color. So I binded these thresholds, so yeah, it will be the same. And there's a blur here or level if you want to adjust it a bit. and it's going to the costume color. So what I changed basically, so before that what we did, we grabbed like a noise or or texture, and inside the the system will fit it into this count, which is basically the number of particles squared, and then it gives us the texture. But now, if we go inside and inside the parameters, so what I'm doing is I'm grabbing the ratio of the resolution of the texture that you put it inside the force, right? So we have the force over here, and with an info, and I grab the resolution, divide it, and I have this ratio. And in the parameters, I'm taking the number of particles, and based on the ratio, I'm calculating the map, the new resolution of the of the simulation resolution, to basically map it that it will be this number of particles. And if you basically press, let's grab the parameters in a window. So if you press yeah, once again, I wanted to show you, let's see. All right, so sorry, it was a buggy thing, but I don't know what happened, but yeah, now it's okay. So without the fit to texture, our resolution is um, this, okay, which is the count. But if we toggle the fit and reset, sorry, you need to reset. That's the thing. That's the bug. It's not a bug. You just basically need to reset, and you get the other resolution, but it's the same amount of particles. All right, and then in the position at the end, I'm using a simple point transform, and I'm adjusting it with the scale. So now it's like a square, right? And after the point transform, it's a rectangle with the same ratio of the texture. Cool. So then what we want is to render it nicely into a render that is also in the same resolution. All right, so we have this render, okay, and this render resolution, I get it in from the input here, which is the texture, and also the home camera, which is referenced with the simulation reset. So inside, in the render, we grab it, okay, this resolution, and also in the camera we use orthographic and the author width, it's the ratio between the width and the height. So that way the 3D or 2D thing here will basically fit the render perfectly. And here I have like post effects, uh, just like simple stuff, not something fancy, feedback, bloom, and the other stuff. Um, yes, and I think this way you can also put anything that you want. Like let's grab um, butterfly maybe. Hmm. Yeah, let's see. Yeah, so reset and then you get it, and it will be the same resolution as this is the original. Okay, and this is actually a low resolution texture, so you can fit it to make it like more to raise the resolution, and then you get like more resolution. Anyway, yeah, I think uh, this is it for the oh right, one more thing. If you don't want to fit the texture, for example, so this opens up and then you can adjust it uh, yourself basically. uh, and yeah, sometimes it's good to do it manually, so I opened an option to do this. um, More stuff that I did actually are change some stuff inside this size to based on velocity and age, and also with the color. um, it's like small stuff, but it's like it made it much more nice to work with. So I'm not gonna go in through this, but try it again and see if you feel the difference, and if it's good enough or you think it should be improved. Please let me know. And also please, if something is not clear about what I've implemented here with this render, also please let me know. Alright, I think we've done with the first and second part, and let's go inside this project now, the 2D particle system with the complex OP. So before we get uh, into the complex OP, I want to show you a quick example of this uh, function store tool uh, thing that I really like, and I really think you should also grab it. It's totally free and it's amazing. He's done really a good work, and like it's very nice to have these kind of things that you can develop inside this software. So a nice thing is these operators presets. So you can see these arrows. Uh, so if I want to grab a noise and to have like a preset that I know that I have before, so I just press like Control and Alt before I put it into the network, and then it opens like a menu, and you can just grab like a preset. Sorry, I'm gonna drink water for a second. Yeah, so It's very helpful for the workflow and like really cool. So go ahead and grab it. Um, so this is an implementation of my system with ComplexOp. So the ComplexOp um, basically Function Store did a tutorial about it. You can see it on YouTube. We link it down also in the description. And it covers up all the functionality of this component. But to make it simple, in the context of our situation with the particle system, this thing can generate forces for particles, but like crazy ones, as you can see here. It's like using a lot of mathematical functions, complex functions, and it's, as you can see, it's just generating like um, really complex UVs that we can uh, implement as a force. So I done and so wait, first of all, there's two components. There's the complex OP and the complex mix. Okay, and the complex OP, it's like the complex functions generator, and the complex mix basically mixes between uh, two complex mixes, two complex operators, and you can basically make a chain, endless chain if you want, with these. I actually didn't use the complex mix yet, um, because only with the complex OP, simple stuff, like not really doing and digging the options, but with just simple setup of it, it's really generating crazy stuff. So let's see. Let's open the panel, and yeah, so this is one example. This panel comes from here. Okay, you can just drag it over here. All right, so this is the first example. So in the complex OP, what I did is I didn't give it an input. Actually, we will see in the next example what happens when you give it an input. And yeah, it has like three outputs actually. Let's put a null here to see all of them. So yeah, this is the mapped output. This is the UV, and this is the borders. So the borders are only, I think, when we put like an input. Let's see. No, I'm wrong. I think maybe it's. I'm not sure. I'm not sure what is the borders, but yeah, I need to watch the function store tutorial again probably. Uh, so actually, I recommend you to watch it before uh, to know about this operator much more. So let's keep it simple. What I did, I took the first input. I used the C exponent operator or function, and you have these op iterations. Um, so I made it with 3, and I played a bit with translate, the rotation, the scale, Yeah, and I think I left everything else like this. So an important thing is that these UV maps are mapping it from 0 to 1. So we have to align it with a point transform. We align it here in the align translate origin, or Y origin and Z origin also, because without it, you see they are, which is also really nice, yeah. Uh, but if you want to align it in the middle, you have to do it like this. Uh, but you see, also this is gives like a very nice result. After it, I just put a ramp um, with the white flipped like this to basically because if you see these this part, it's like very small, and sometimes, and so I like to reduce it a bit, uh, and it gives like a different kind of look basically. uh, but yeah, it's just like a small thing. And also I think I've added a bit of noise, that without this it looks like flat, and with the noise it makes it looks a bit more like 3D-ish. So the noise, it's just a simplex 3D with those values. And of course you can try to play with it. um, and a null at the end, and I put it into the external force with this amount of force. You can also play with it, and yeah. And also in the render tab, I did like this fade in fade out thing, because without it it's doesn't look good. And the size I made based on the velocity, so with the constant uh, it looks like this, and with the velocity it looks like this, so makes it a bit more organic, in my opinion, of course. Cool. And of course inside the render, it's the same render from the other project file, with the post effects. You can play with it afterwards. Alright, so the other example, let me show you. We put this force here, and with this example I'm using the slope because our force it's black and white. I've used the slope, and I think I used the perpendicular, yeah, maybe a bit like this, and then I can use also the filter. Yeah, I think this was the result. So here what I'm doing is I'm actually mapping this ramp. So I'm grabbing the resolution from the simulation with the count, and I'm putting it into the ComplexOp, and as you can see, it's mapping it into the texture based on this operation. So I use the C power, and you can see what happens if I change the power. Um, let's actually make it 2. And rotation, I think it doesn't really matter because it's symmetric. Yeah, and repeat here because I think the other ones, yeah, will be different, which is, this is also nice. Yeah, everything you change here in the ComplexOp, suddenly crazy stuff happens, so be aware. Um, yeah, and also added a noise here, which the amplitude is now 0, but if you add a small amount of noise, makes it also nice. Um, yeah, I think this is it. And of course you can play with the colors, and you can also play more with these parameters, and of course go grab the ComplexOp right now and try it yourself because really it's amazing. uh, I wouldn't know how to create those, UVs without it. Basically you can start, like, I think I did it in the last tutorial. You can grab like ramps, like and like make it like this, and maybe like this, and start like creating those stuff, which can also probably be nice, uh, or not. Yeah, I think the noise is messing around with it. Yeah, so yeah, it's also nice to create those with just with ramps and stuff. um, but this tool is like much more easy to and you see this is like very complex, right? Okay, I think this is it. This whole project file will be available in my Patreon, uh, and of course if you have any questions, uh, please let me know. uh, and yeah, have a nice day. Bye bye.